Alright, let's look at some the trig functions of angles in standard position. So hopefully you can remember that sine ratio. The sine ratio is opposite over hypotenuse. The cosine ratio is adjacent over hypotenuse. And the tan ratio is opposite over adjacent. So things that you should have known already back in Math 9, 10, and bit in 11. Say we had to do the sine of 34 degrees. Remember, we just take the calculator, and if we want to know what is the sine ratio of 34 degrees, then we can simply enter sine 34 on the calculator. And what we need to do is we need to make sure that the angle is set up in degrees. So make sure you know on your calculator how to convert between degrees and radians. If you don't, you might want to see me to figure out how to do that. So when I punch in the sine of 34 degrees, it gives me a ratio of 0.56, 0.56. In other words, if I had a 34 degree angle, the opposite side divided by the hypotenuse side of that triangle would be 0.56. Now if we did one in radians, so this is new. Okay. Say we had an angle that was 2.1 radians. Well, changing my angles from degrees to radians now. Now when I punch in the sine of 2.1, it says the ratio would be 0.86. So we need to be able to work with degrees, we need to be able to work with radians, and you need to make sure that you have your calculator in the right units when you're doing your work with these angles. Now let's say I'm asked a question here now, and the question says, find another angle that when I take the sine of this other angle, so some other angle here, see if you can find another angle that when you take the sine of it, it would also end up as 0.86. Well, remember, a coterminal angle would be an angle that would have the exact same terminal arm. So if a coterminal angle has the same terminal arm as this one, then obviously it must have the same ratio. So all I need to do is take 2.1, and if I added 2 pi to that, I get about 8.38. So really what we've done here is we had an angle of about 2.1 radians, and we said, well, hey, let's just go around once more and add 2 pi to that. So that ended up being 8.38. And just to double check, if I go sine of 8.38 on my calculator, I end up with 0.86. Now here's a real important concept. We're going to take a look at what happens to the sine, cosine, and tangent ratios as we look at the ratios in each of the different quadrants. So what I've got here is I've got a circle. Let's just assume that this circle has a radius of 1. All right? So it's a circle with a radius of 1. So this point's 1 on the x-axis, this is 1 on the y-axis, minus 1 over here at negative x, and negative 1, a circle of radius 1. If we take a look at an angle, so here's my initial arm, what we're going to do is we're going to rotate our terminal arm, rotate our arm through the 4 quadrants and observe what happens to the trig ratios. So let's take a look first of all at an angle in quadrant 1. Here would be its terminal arm. So here's angle theta. If I dropped a perpendicular down here, then I've made myself a right triangle, and I can talk about what the sine, cosine, and tangent ratios would be. So we know that this hypotenuse will be 1 because this is a circle of radius 1. So our hypotenuse will always be 1. This will be some x value, okay, obviously something less than 1, and this will be some y value. But the important thing to know here is that x is still positive and y is positive. This is positive x, this is positive y. So if I was asking what is the cosine of theta, you would say it's adjacent over hypotenuse. Adjacent over hypotenuse is a cosine ratio. Remember SOHCAHTOA. But cosine then would be a positive ratio in this quadrant, because positive divided by positive is a positive. The sine ratio would be positive as well. Opposite over adjacent, positive. Y is positive. And tan, since all three of these are positive, tan is opposite over adjacent, it too is positive. So all of the three trig ratios are positive in quadrant 1. Let's look at what happens when this angle moves into quadrant 2. Okay, so we've rotated our terminal arm in now to quadrant 2. We'll draw our triangle. Okay. Now I think you can see that the x value here will be negative. We're in the negative x side of the axis here. However, y is still positive, going up, and our radius is still 1. Let's look at what happens to cosine now. Cosine is adjacent over hypotenuse, so you've got a negative value divided by a positive. Cosine is now negative. Sine, opposite over adjacent, positive divided by positive would be a positive. And tangent is opposite, positive, divided by adjacent, negative. Tan is negative. So the only thing that's left positive here is sine. Sine is positive in quadrant 2. It's the only one. Moving into quadrant 3. Drawing our terminal arm. There it is. And dropping a perpendicular to the x-axis to make a triangle. We now have a negative x value here and a negative y value on this side. So working with our reference angle here, let's see, we're starting with cosine, and radius of 1. Cosine is adjacent over hypotenuse. Cosine is negative. Sine, opposite over adjacent, opposite over hypotenuse. Sine is negative, but tangent, opposite over adjacent, a negative divided by a negative makes a positive. So in quadrant 3, tan is the only ratio that will end up being positive. Finally, if we drew an angle in quadrant 4 and dropped our perpendicular down to the x-axis, we have a positive x again, but we have a negative y value and a hypotenuse of 1. So cosine would be adjacent, where's our angle here? Adjacent over hypotenuse, that's all positive. Sine, opposite over hypotenuse, a negative divided by positive is a negative. And tangent would be negative divided by positive, opposite over adjacent. Tan is also negative. So in this quadrant, the only thing that seems to be positive is cosine. So we have all ratios positive in quadrant 1, sine positive in quadrant 2, tan positive in quadrant 3, cosine positive in quadrant 4. And this is very important, this understanding of these ratios, especially when it comes to solving trig equations, Learning Guide 11-12. So we need a little way of remembering which quadrant has each of them positive in. And if we work through from quadrant 1 to 4, here's how you'll remember this. All students take, you got it, calculus. All students take calculus would be a way of remembering the positive trig ratios in each of those quadrants. Let's look at this question here. We're told theta, the angle is going to be in quadrant 1, and that the cosine of that angle is 3/5. So it asks us to draw the angle theta in standard position. That's the first thing. So I'm just going to put some angle here in quadrant 1. There it is, some angle theta. Okay, so there's angle theta. I need to make sure that the cosine ratio, so I'm going to drop my perpendicular down to the x-axis. I need to make sure that the cosine of that angle is 3/5. Well, cosine is adjacent over hypotenuse. All right, so I've drawn the angle in standard position. Now it asks me to determine a point P on the terminal arm. Well, here's the terminal arm right here. This, of course, extends on. I'm going to use this point right here because it's very easy for me to tell what the x value is. X would simply be 3. And I need to determine what this height is on the triangle here because this would be my y value. Remember, this is x, this is y. I need to find out what this side of the triangle is. Well, with the trig ratio, you're always going to know two sides. We knew that this was 3, we knew the hypotenuse was 5. So Pythagoras' theorem will allow us to find this side here. And so, remember, a squared plus b squared equals c squared. So let's call this a. We don't know this short side. A squared plus 3 squared, which is 9, equals 5 squared, which is 25. If I subtract 9 from both sides, that's 16. And I square root, taking the positive solution, I get a equals 4. So a point on my terminal arm must be 3 for x, 4 for y. That would be one possible point on the terminal arm. Let's look at one more example. This one says theta is in quadrant 2, and sine theta is 2 over root 5. Well, let's see, quadrant 2, that's over here. And yes, sine should be positive. Remember, all students take calculus. So we're not surprised that sine theta would be positive in quadrant 2. If I drop my perpendicular, sine is opposite 2 over hypotenuse root 5. And so here's my angle theta in standard position, measured from the initial arm to the terminal arm. I'm working with my perpendicular triangle down to the x-axis, so that here for point P, I know the y value is going to be 2, right, because there's a height of 2. I just need to find out what x is. So if I square this, that's 5. I square this, that's 4. 5 minus 4 is 1. And if I square root 1, I get that this side of the triangle is 1, but I need to be careful because here I want to accept the negative solution because x is negative on this side of the y-axis. So what is this point here? It would be left 1 up 2. Negative 1, 2. So for Learning Guide 8, make sure that you can convert between degrees and radians, that you understand what a radian is, and you can define it, and that you're able to work with angles in standard position. You know about coterminal and reference angles, and that you can work through a problem like this where we're given a trig ratio, you draw it in standard position, and you come up with a point P on its terminal arm. Let's say we're asked to find out what the sine of 45 degrees is. Well, you would get your calculator out, you would make sure that you're in degree mode, and you would punch in sine of 45, and you get some irrational number, some decimal that goes on and on and on, and you would probably say this is 0.71 if you were rounding that to 2 decimal places. But in this expectation, we're asked to come up with exact trig ratios for some specific angles. So the ones that we need to know exact trig ratios for are 0 30 degrees, 45 degrees, 60 degrees, and 90 degrees, as well as some multiples of those angles. So what that means is we must memorize or be able to calculate exactly, in other words without a calculator, the sine, cosine, and tangent of all of these angles in degrees and in radians. Their corresponding radian measure would be these. So let me show you how we can find out what the exact trig ratios are for those functions without a calculator. I'm going to draw a triangle here. I'm going to make this an isosceles triangle. I'm going to make it a 90-degree triangle, so an isosceles right triangle. Remember, isosceles means it has two sides that are the same length. I'm going to make them 1. If this angle is 90, the remaining two angles must add to 90 and must be equal because it's isosceles. So I've got 45, 45, 90 triangle where this is 1 and this is 1. And I can determine this side because I can use Pythagoras' theorem. A squared, 1, plus other side squared equals hypotenuse squared. 1 squared plus 1 squared is 2. And square rooting, I get that the hypotenuse would be root 2. So now I can find out exactly what is the cosine of 45 degrees. Well, cosine is adjacent over hypotenuse. So without a calculator, I know that cosine of 45 is 1 over root 2. And the sine of 45 is also opposite over hypotenuse, so also 1 over root 2. And tan 45 is opposite over adjacent. Opposite over adjacent is 1. So if we can remember this triangle, then we can determine what the exact values are for the angle 45 degrees. And of course 45 degrees is the same thing as pi over 4 radians. So I could say the cosine of pi over 4 would also be 1 over root 2. The sine of pi over 4 would be 1 over root 2, and the tan of pi over 4 would equal 1 over root 2. Let's draw another triangle. This time I'm going to draw a triangle that's an equilateral one. That means all the sides are the same length. And I'm going to make them all worth 2. Now from my apex here, I'm going to draw a perpendicular straight down to the bottom of this triangle. That will cut this triangle in half. And so this side of the triangle is now 1. And this other half would have been 1 as well. I said this was an equilateral triangle, so that made all these angles originally 60 degrees. And if I just split this in half, then this angle up here is now 30 degrees. Now if I erase my right half of that original equilateral triangle, I now have a 30, 60, 90, where I know this side is 1 and this side is 2, and I can calculate the short side here, again using Pythagoras. 2 squared is 4, 4 minus 1, when I bring this over to this side, is 3, and so square rooting, Pythagoras would tell me that that side would be root 3. And now that I have this triangle, if someone said, well, what is exactly the cosine of 30 degrees? I can say it's adjacent over hypotenuse, root 3 over 2. Or what is the tan of 60 degrees? I can say, well, that's opposite over adjacent. Root 3 over 1. And 60 degrees, of course, if you convert this to radians, is pi over 3. And 30 degrees would be a sixth of pi, pi over 6. So whether they wanted it in radians or degrees, we could give the exact same, exact ratios for each of those angles. So if you can simply remember these two triangles here, okay, the 1, 1, root 2 triangle has angles of pi over 4 or 45 degrees, same thing depending on what units we're using. Then you could find the sine, cosine, and tan ratio of 45 degrees by simply using the appropriate sides of this triangle. Or if they ask for 30 degrees or 60 degrees, pi over 6 or pi over 3 radians, then again, you can use your trig ratios using the three sides of this triangle. So if they asked for the cosine of 60 degrees, you could say it's 1 over 2, adjacent over hypotenuse. So you must memorize these two triangles or be able to draw them so that if someone asks you what is exactly the sine of 30, you could say it's opposite over adjacent, 1/2, 1 over 2. The other angles that you said you needed to know was 0 degrees and 90 degrees. But for these ones, the sine, cosine, and tangent ratio are all going to be either 0 or 1 or undefined. So you can actually get these answers exactly on your calculator. You don't need a special triangle because the answers are exact. So for instance, if I type in the sine of 0 on the calculator, it gives me 0. So we don't have to worry about 0 and 90 degrees for special triangles for that, because the answers are either going to be 0 or 1, and your calculator will tell you exactly what those are. It's just 45, 30, and 60 that we're going to have possibly square roots in our answers. So let's look at how we can use this to answer some questions. The exact value of sine pi over 3. Let's say we're asked to find out what is the exact value of sine pi over 3. Well, if I construct my 1, 2, root 3 triangle, where this angle is pi over 3 and this angle is pi over 6, then I just simply need to take a look at pi over 3. Here's this angle. Sine is opposite over hypotenuse. So that angle would be root 3 over 2, straight off the triangle. Now we're asked to find the exact value of cosine of 3 pi over 4. You're probably thinking, well, we don't have a triangle that has an angle of 3 pi over 4. We have pi over 4, and we have pi over 3, and we have pi over 6, but not 3 pi over 4. But watch what happens when we draw this in standard position. Okay. So, remember, here's 0, here's pi over 2, here's pi, this would be 3 pi over 2. 3/4 of pi would end up right here. Our terminal arm would be 3/4 of the way to pi. We can always get the exact same trig ratio by working with our reference angle. So what is the reference angle here? The reference angle is pi over 4. Because if we're 3 pi over 4, then the missing piece would be 1 pi over 4. We can know exactly what the cosine of pi over 4 is. That's coming from the 1, 1, root 2 triangle. So the cosine of pi over 4 is adjacent over hypotenuse, 1 over root 2. So the cosine of 3 pi over 4 must be also 1 over root 2, but we have to make sure of one important thing. Remember back to this? All students take calculus. In this quadrant here, the only thing that's positive is sine. So since we've got a cosine question, this ratio simply must be negative 1 over root 2. Okay, we're in the second quadrant, cosine must be negative in there. So all of these questions that we're working with, or we'll always be working with our triangles, with either pi over 4, pi over 6, or pi over 3, we just need to determine is it positive or is it negative based on these 4 things. Let's look at this one final question. What is the exact value of tan negative 7 pi over 3? Alright, I'm going to draw this angle in standard position so I know which quadrant it's in. This is a negative angle, so I'm going to be spinning this way. And I know that 7 pi over 3 is what? 2 1/3 pi? 3 goes into 7 twice and leaves 1/3 remaining. So this is negative 2 1/3 pi. So starting here, there's 1 pi, there's 2 pi, and now I need to go 1/3 of the next pi. So this would be the angle here, negative 2 1/3 pi, or negative 7 pi over 3. And I'm looking for the reference angle. I must determine my reference angle. My reference angle obviously would be 1/3 pi, pi over 3. So now I need to determine what is the tan of pi over 3. You'll get so good at drawing these triangles. That's the 1, 2, root 3 triangle, where this angle is pi over 3 and this angle is pi over 6. What is the tangent of pi over 3? Opposite over adjacent, root 3 over 1. So this will equal root 3 over 1, or just root 3. And I need to determine whether this is positive or negative. All students take calculus. We're in this quadrant. Calculus is the only positive ratio. So tan must be negative in that quadrant. The correct ratio would be negative root 3. Now, we've got some brand new functions to take a look at here. Y equals secant x, y equals cosecant x, y equals cotangent x. Okay. These trig functions, these 3 new ones, are really just reciprocal functions of the other functions, the other 3. So secant is the exact same thing as 1 over cosine x. It's the reciprocal of cosine x. And I kind of remember that because it almost looks like cosine x spelled backwards. This one is the reciprocal of sine x, and cotangent x, as you might have guessed, is the reciprocal of tan x. So if cosine x was adjacent over hypotenuse, secant x, being the reciprocal, this is hypotenuse over adjacent. And if cosecant x is 1 over sine, and sine is opposite over hypotenuse, then this ratio is hypotenuse over opposite. And if tan is opposite over adjacent, then cotangent would be adjacent over opposite.